Welcome to video lecture number 3 for the solutions unit. In this video, I'm just going to quickly touch on a couple of tricks and tips to help you with the more advanced molarity problems. The last assignment that you did was very straightforward. You just had to figure out the equation to use to plug the numbers in and plug it into your calculator. However, the problems can get harder, which they are going to in this next assignment, so I want to run over some things to remember to help you with those problems. So the first thing to remember is that N is equal to moles of solute. If I were to give you the amount of solute in grams, you have to do a mole conversion first, so that you are plugging in the moles of that solute into your equation. You cannot plug grams into the equation. Okay, so that's a simple mole conversion like we've been doing throughout the year, where you would just use the molar mass to convert grams of a compound or a substance into moles using the periodic table. And if you have to do if you have to calculate out N, just be aware what the question is asking for, because sometimes I will ask you for moles of solute, but sometimes I will also ask you for grams of solute. Really, when you are actually measuring this stuff out to make a solution, if you just have the amount of moles that you need for a substance, that doesn't help you when you are using an electronic balance. You have to convert it into grams because that's what the balance measures in. So just be very aware of what I'm asking for. I'll try to be very clear whether or not I want your answer in grams or moles. Okay, and again, the way that you would convert between the two is a very simple, it's a basically one-step mole conversion. The other thing to remember is that V is for liters of solution. Okay, if I were to give you another unit, for instance, I like to use milliliters, I could use kiloliters, I could even go into gallons. You have to convert that unit that I have given you into liters first before you can plug it into your equation and get your answer. So the way that you would do this, if I give you milliliters or kiloliters, you would just use your metric stairs. Remember, for every stair you move to the right, you move the decimal one space to the right, and for every stair you move to the left, you move the decimal one space to the left. Or if I ask you, or if I give you a number or a volume in gallons, you would have to go through dimensional analysis using the conversion factors that are given to you on that metric staircase. Okay, so hopefully you remember how to do that. So just remember that these are very specific units. You have to have them in the correct unit in order to plug them in and get the correct answer. Let's try a practice problem. What is the molarity of a solution containing 1.55 moles of sodium chloride in 675 milliliters of solution? Now I bolded and underlined the 675 milliliters because we need to get this into liters before we can actually plug and chug. So I'm going to start this the same way I started the other ones, where I look for what it's asking me to find. It's asking me to find molarity. So then I go to my triangle. I cover up molarity with my finger because that's what we're trying to find. I know that my equation is going to be M equals N divided by V. So I'm going to write that out first. Next, I'm going to plug my numbers into the equation. So I'm going to start with 1.55 moles is my N, and this would be my V, but we need to convert that first. So if you have your metric stairs, you can find the box that has milli, which is at the bottom, there we go. And liters, which is what we need to get to, is the base unit. So going from milliliters to liters, you should find yourself going 3 boxes or 3 spaces to the left. So we are going to move the decimal on this 675 milliliters 3 decimals to the left to turn this into liters. So because you don't see a decimal in this number, you assume it's at the very end. So 675, here's my decimal, that's milliliters. To get to liters, we move this decimal 1, 2, 3 to the left to give us 0.675 liters. That's the number we plug in for V because liters is what it needs to be in. So I'm going to plug these numbers in. M equals 1.55 moles divided by my 0.675 liters. I'm going to plug that into my calculator, and I should get a molarity for this solution around, we'll round to 2.3 molar. Let's try another practice problem. What is the molarity of a solution containing 150 grams of calcium chloride in 4 liters of solution? Again, I'm going to go through the problem and figure out what my unknown value is. It looks like we are again looking for molarity. Molarity is M, so we cover that up on our triangle. That means that N divided by V will give us our molarity. I'm going to write that out first. M equals N divided by V. Next, I'm going to look for my known values in the problem. So this 150 grams, I'll have to convert that into moles, but that will be my N. And this 4 liters of solution will be my V. So let's start by converting 150 grams of calcium chloride into moles. Now I'm going to bring back the naming here. Calcium chloride. Calcium is Ca, has a +2 charge. Chlorine is Cl with a -1. Those crisscross to give us the formula CaCl2 for calcium chloride. So we are going to do our dimensional analysis. 150 grams goes in the upper left-hand box. Next, we need to figure out the molar mass of calcium chloride. Calcium chloride contains 1 calcium and 2 chlorine. Looking at our periodic table, 1 calcium is 40 grams per mole. So this 1 is going to be multiplied by the 40 to give us 40. And chlorine is 35.5 grams per mole. We're going to multiply that by the 2 to give us 71. We add those two values up to get 111 grams per mole. So since we have grams of calcium chloride up, we need to put this 111 grams of calcium chloride down, and that is how many grams are in 1 mole. Now my grams cancel out. I'm left with moles. I can plug this into my calculator. You should get an answer of 1.4 moles. So this will go in for my N. M is equal to 1.4 moles of solute divided by my volume of 4 liters. I'm going to plug this into my calculator, and you should get a molarity of 0.35 molar. Let's try another problem. What is the molarity of a solution containing 150 grams of sodium fluoride in 10,450 milligrams of solution? Now notice how both the N value, 150 grams, and the V value, 10,450 milliliters, both need to be converted this one into moles, this one into liters before we can do any calculating. So I'm going to start first by looking at the problem and determining what I need to calculate. So my unknown, what I'm asked to find, is molarity, which is M. So I cover up the M. That means that N divided by V will give me my molarity. So I'm going to write that out first. Next, I'm going to go through the problem and I'm going to do some converting of my known values. So let's start with my N. This is my N value, 150 grams of sodium fluoride. We need to convert that into moles. So I'm going to do that down here. I'm going to start with that in the upper left-hand box of my dimensional analysis. But before we get into the dimensional analysis, we need to convert this name into a formula. Sodium, we know, is Na, has a +1 charge, and fluoride is F with a -1. These are equal and opposite, they cancel out, and we are left with just NaF. Next, we need to find the molar mass of sodium fluoride to convert this into moles. So that's how many grams are in 1 mole. Now, sodium fluoride contains a single sodium and a single fluorine. Oops, one of those. On our periodic table, sodium is 23 grams and fluorine is, let's round that to 19. So we have one sodium at 23 grams at 23 and one fluorine at 19 grams gives us 19. We add these together to get 42 grams per mole. So this number is going to come into my dimensional analysis. My grams cancel out. I'm left with moles. Now I can plug and chug. When I plug that into my calculator, I should get an answer of 3.6 moles. So that's my N value. I'm going to go ahead and plug that in, 3.6 moles. Now for my V value, which is this 10,450 milliliters, I need to convert that into liters. Now, since there is no decimal in this number, I'm going to put it at the end. And remember to get from milli, the box on your metric stairs that says milli, up to liters, which is base unit. You are going to have to move 3 stairs to the left, which means that in order to move or to change this into liters, I move the decimal 3 spaces to the left. So we go 1, 2, 3. This is where my new decimal is. So 10,450 milliliters is equal to 10.45 liters. This gets put into my equation as V. And now I'm ready. Now I'm ready to plug and chug. When I put that into my calculator, I should get a molarity of 0.34 molar.